Hello there in this new video in which we will see a machine learning lifecycle management with MLflow with an example of handwriting digit recognition, which is an image classification. For training a machine learning model, we need lots of data. Fortunately, there is a database called the MNS database. This has us covered with 60,000 images for training the model and 10,000 images for testing the model. The model is our program. It enables us to feed an image and get a prediction. It uses an input for generation, output. So, in this video, we want to create and train a model that takes an image of a handwritten digit as input and predicts the class of that digit. Then we will implement the MLflow components, which can be leveraged to organize the machine learning workflow. Before moving to our example, it's very interesting to know that most data scientists and ML engineers are able to create a model on their laptops and desktops. They may use Anaconda, Jupyter, or other editor. But there are some problems when they have to improve their model performance over time and when multiple members of a team are working on the same model. Some problems or such as keep track of all parameters tuned and tweaked in the model, keep track also of the outputs, accuracy, error score, maintain the records of model on their related data object. In addition of the problem of the version their models share with team members. What are exactly the prerequisites? Set up model in the place for other members to run the model on their system. It's really a big problem. So MLflow is what we need to solve this problem. It's a powerful MLops tool for machine learning model tracking, versioning, packaging, and so on. It's really one of the best open source projects in the data science community because it redefines feature organization and jumpstarts the creation of your feature factory. So let's start and discover MLflow in our example. It's possible to apply MLflow locally as well as on the cloud. In our example, I will use MLflow locally and I used Spider Anaconda as an editor. So here are the steps to follow to set up a model to predict handwritten numbers. So before starting anything, make sure that TensorFlow, NumPy, Keras are installed in your computer. Here we import Matplotlib for visualization and analysis part, and those are the package for CNN architecture, such as layers, dropout, max pooling. I will explain them on the architecture. I will use them for or to get real image and test them. Now the necessary library for implementing MLflow is the import MLflow. By default, MLflow uses local stores to run the tracking server. MLflow does provide the option to track runs to a remote server as well. This can be done by calling MLflow set tracking. The remote tracking server can be assigned using SQL link, local path, local file path, or HTTP server, or even a data lake path. Here we use our URL server, which is localhost with the port of 5000. Let's start loading our dataset, and in which data is split between train and test sets. Then I displayed the shapes of imported array, and as a result, here the first component represents the number of examples in the array, and for each example, there are a squared array of number of pixels. In this case, For the train case, there are 60,000 image example, and for each image, there are a matrix of size of 28 pixel. Here we print the number of our classes, which are 10 classes, beginning from 0 to 9. Let's plot an image example with emshow here for matplotlib. And these are the x-train of 0, which is 5. Many machine learning algorithms cannot operate on label data directly. They require all input variables and output variables to be numeric. So this technique to achieve this is called one-hot encoded. Is doing on our Y-train and Y test, and after this encoding, every label will be converted to a list with 10 elements, and the elements are indexed to the corresponding class, which be set to 1, which is his 5. So here we have 0, 1, 2, 3, 4, and 5 mentioned 1. Now the dimension of the training data is 60,000 example 28 pixel. But CNN accepts 4 dimensions. So we need to reshape the image to have dimensions like that: samples, width, height, and pixels. We need also to normalize input and to change the values of numeric columns to dataset to common scale without distorting difference in the range of value. This involves first converting the data type from unsigned integers to float, then dividing the pixel value by the maximum value, which is 255. Let's see now how to create our model. We need to define a baseline convolutional neural network CNN model, but it's first of all recommended to initialize the hyperparameter outside of code to facilitate the task of changing values. Let's discover the CNN architecture now. Here we have a sample CNN model, beginning with mentioned that we will work with sequential model. convd here we use convd since we will deal with image designed for feature extraction. It will specify the pattern retained at 1 and rejected at -1. For the ReLU activation, this is the activation function that will keep the retained patterns at 1 and rejected at 0. We will use max pooling to reduce the number of parameters and increase performance. For the dropout, it's used to manage and avoid overfitting. Flatten allows here to take the last max pooling matrix into a single array type vector, and the dance of sure to deal with fully connected layer or to activate our neural network. For the activation, which is equal softmax, because here we have multiple classes. Let's see now the summary of our model. Here we have the summary of this CNN model. Here for the first conv 2D, we begin with 2626 because we can't use a 1 pixel margin around the image, so the convolution output will be 2 pixels smaller on the X and 2 on the Y, hence 2626. Now it's time to compile and fit our model to test its performance with the optimizer and the loss function. We take as a number of epoch mentioned in the hyperparameters, which are 10 epochs. So for 20 epoch, our model is performed with value accuracy of 55%. And as a loss function, here we have 26%, meaning our model is performed. Now our model is prepared with high validate accuracy. So it's time to implement MLflow or to run this experiment on the interface MLflow. Here I decide to save MLflow in localhost with tracking server. So a tracking server is launched listening for REST requests, calls at the default port, which is 500. So in the folder of our program, we will use the tracking server. The argument supplied to the MLflow server is dedicate what backend and artifact stores are used. The default is local file store. For example, if I use or I launch a tracking server as MLflow server with backend store URL is the SQLite, then SQLite will be used for backend storage instead. And here we find our repository with the repository of artifact and the database of MLflow in which each run or each experiment will be stored. So here are the ID of the runs. Here we have our serving or URL of our interface, localhost for the port 5000. Here is our MLflow interface. Here, experiments is the name given to a group of server execution. So MLflow stores all the runs under default experiment name. It's by default. We can also assign an experiment name by using set experiment before calling the start run method, which will create a run in this experiment. But here let's take it as a default. MLflow tracking keeps track of execution by recording metrics and some parameters, tags, and artifacts. It allows us to view and also to compare them in a browser in an easy way. For example, let's take this model run with this one. Click to compare, and this is some comparison between the two runs. Here we have the run ID, the run names, some hyperparameters such as batch size, number of epochs, and others. And the most important part is to compare metrics such as accuracy, loss, validate accuracy, and also validate losses. So let's take an example of visualization. The most important thing here to compare is for each model, let's compare accuracy and validate accuracy. Accuracy is the number or the percent of predicting value as true for the train part and validate accuracy for the test part. So here, according to the analysis of this comparison, we distinguish that the MNISTRAN1 model having a accurate value greater than the validate accuracy of the model MNISTRAN2. So we can here have a conclusion that MNISTRAN1 will be the best model to be in production. So let's go on we can do many visualizations, such as visualize the point for each value. You can also see the loss and value. So here we said that MLFLOW is the model to be in production. And this is the most important part in MLFLOW. This is the part of MLFLOW project, which is a format for packaging code. It uses artifacts recorded at the follow-up stage. So the ML project file here is used to define the name of the project, the environment that is used, which is seen in Anaconda file, which defines the environment dependency for the project. So wherever the member of the team which would have the same project in his laptops, so he needs these dependencies. We can also see the model summary for our CNN model. Here is the ID for our model. So now, since we are going to deal with the model, this model as production, it's time to register the model. In fact, the MLFLOW model registry component is a centralized model store, a set of APIs and UI to collaboratively manage the full life cycle of a model or an MLFLOW model. So here we will create a new model, or we will specify a name for this model. For example, I will take MNIST version 1. I will register this model. So here it's created MNIST v1, and here on the model part, the model is created. So it's time to keep this model on production, or we can monitor their stage, which are staging, production, and archived. So this model will be in production. I will click in production. If we have another model in the production, it will be archived. And this is our model in the production. So I will keep some tags for my team. For example, the data scientist Farah. It's up to you to check this model. I can also make some description about this model. It's, for example, this dataset is validate, or whatever information. Now, if we go on to the experience page, here we have mentioned that our model is in production. And this is the most important part in MLFLOW, or the benefits of MLFLOW, which can be used to perform one-click project reproduction and model deployment functions, which is also equivalent to one-click online deployment. There is no need to rewrite the code in the project and no environment configuration. So MLFLOW is very interesting. It allows you to track your process as you'd like, and frees data scientists to get back to doing what really matter. Every hyperparameter tweak, every feature change, every possible metric you can think of, all recorded in one organized location. It's very helpful for an MLOps team. So